Okay, so we are discussing kinematics, right? So today we will do graphical analysis. Okay, so graph tells us a lot of things, and mostly we have observed many questions are being asked in exams based on graphs. Okay, so first we will discuss some position versus time graph. Okay, listen carefully. Okay. So this is distance versus time graph. Okay, position versus time. Okay, so I will draw some graphs here. Okay, so you all know that velocity is equal to what, dear students? Dx by dt. And what is acceleration? dv
dv
by dt. Yeah, talk like that. So if you speak, I will also get some energy. Okay, if you interact more, it would be good for both of us. Okay, so and if acceleration and velocity both are in same direction, it will speed up or speed down?
speed up.
Speed up. If they are in opposite direction, speed down. Okay, so from position time graph, dx by dt is your velocity. That means dx by dt is nothing but slope. Okay, slope of the xt graph is nothing but velocity. Write down this. Slope of position versus time graph is velocity. Why? Because if you guys know, right, in any if I give x and y and this is x. Okay, so you know that if there is any line, the slope is given by y by x, right? dy by dx, that is nothing but tan theta, this angle theta. The slope is given by dy by dx. Now we are discussing what? X versus time graph. So dx by dt is nothing but what? Slope. This is slope, right? So this is also slope. That slope is nothing but velocity in xt graph. Any doubt here?
No, sir.
No.
So
So now you guys tell me, what is the slope in first graph? What is xt? What is the slope in the first graph?
it is a linear graph, no? Like constant.
Yeah, it is constant. So if x is constant, then dx by dt is differentiation of a constant is what?
0.
Zero. And also you know, right? You guys know that if I simply draw a line, what is the slope? Zero, right?
Yes,
If I
sir.
start increasing like this, the slope is increasing. Correct?
Yes, sir.
And if I go like this also, the slope is increasing. So this is what? Increasing slope. This is also increasing slope. Correct? Now you come here. In the first graph, x is constant means slope is what? 0. So in this graph, velocity is 0. Correct? If velocity is 0, acceleration will also be 0. Because a is equal to dv by dt. V is 0. A is also 0. Come to the second graph. Come to the second graph.
So
What
it
is
is
the velocity?
uniformly increasing, no?
Yeah, it is uniformly. What is increasing? Position is increasing with time, right?
Yes, sir.
So if this is the time, this is the position. This is the time, this is the position. But the rate of change is constant. This is a line, right? The slope is fixed. Is there any slope changing? Is the slope changing?
No,
No,
sir.
sir.
This constant slope. Constant slope means constant velocity. V is equal to constant. If V is constant, what is A? 0. Because A is equal to dV by dt. Come to the third graph. So now you guys tell me what is happening to the slope. Is it increasing or decreasing?
Increasing.
Slope is increasing. First, before that, let us draw the path, how the particle, you see, all the graph I'm showing is for one particle which is moving or which is at rest, which is speeding up or which is speeding down. Okay, in the first graph, I will draw the path diagram. Let us say this is my origin. Okay, here, let's say this x value is 2. So the particle is at 2. It is not at all moving. X equal to 2. This is the path graph. Okay, second, tell me guys, this is the origin and the x is increasing, right? X is increasing and velocity is constant. So you can say the particle starts from 0 and it is going to infinity. With constant velocity, it is moving, right? All right. Come to third. Come to third. Tell me what is happening to the slope. It is increasing, right? As you are moving forward, the slope is increasing. So just tell me, x is increasing, slope is increasing. That means velocity is also increasing, correct? What is velocity? Velocity is the slope. If the slope is increasing, velocity is also increasing. So if it is velocity is increasing means speeding up, right? Speeding up means acceleration and velocity both are in same direction, correct? So again, if I draw the path, the particle is starting from origin and it is going with speeding up. Okay, here you can say V is also positive, A is also positive. That means speed up, correct?
Yes, sir.
Yeah, come to the this graph. What is happening to the slope here?
So like it's increasing and then it becomes constant with respect to time.
Yeah, so this velocity is decreasing. This you first comment on slope. Slope is decreasing. That means velocity is decreasing, correct? So, and the slope in throughout journey, the slope is positive or negative, dear students?
Positive, no, sir.
Yeah, V is positive, but but it is decreasing. That means my acceleration has to be
Ne Zero.
negative.
But sir,
Negative.
acceleration cannot be negative, no.
Negative, I means it is opposite direction of the velocity. Then who is decreasing the velocity? There has to
But
be some acceleration, right?
but sir, in this graph, like
Mhm.
it is increasing and then it's becoming constant, no, with respect to time. So
Yeah.
how is the slope decreasing?
See, let me show you. I think you have confusion. See, in that graph, first the slope was like this, right? Then it is like this. Then it is like this. Then it is finally becoming zero, right? See, flat line means zero slope.
Yes, sir.
That means slope means what? Dx by dt, which is nothing but velocity. If slope is zero, velocity is also zero.
Got it, sir.
So, so velocity, but the slope in throughout the journey is positive. That's why my velocity is also positive. But the velocity is decreasing. If the velocity is decreasing means both the acceleration and the velocity are in opposite direction. This thing will come in picture. We discussed, right, when in last class, when you throw a ball up, it is going up and it is coming back because the velocity is continuously decreasing because of acceleration due to gravity. Both the velocity and acceleration were in opposite direction. Understood? So here speeding down. So how I will draw the path? So here the velocity will be like this. Acceleration will be in opposite direction, right? So it will go like this and it will come back. Okay. In this case, V is also in this direction, A is also in this direction. So it will continue going in this direction only. Come to the third, 1, 2, 3, 4, fifth graph. Tell me what is happening here. Initially, the slope was like this, zero slope. Then it was like this. Then it is like this. Then it is. Tell me the slope is increasing or decreasing?
Decreasing.
Increasing.
Decreasing, sir.
Increasing.
Okay.
Check. No, slope means you understand, right? If I tell you to walk on this floor and this is first floor, and if I tell you on walk on this second, which one you will feel more difficult? Second one, right? Doesn't matter if it is like this or like this. Even in this case, this is first and second. On second, it is hard to walk because the slope is more. You can slip off. Understood? So the slope is increasing, but the slope is negative here. Correct?
Yes, sir.
Slope is negative here. So slope is increasing, but slope is negative. That means velocity is negative. But slope is increasing. That means velocity is also increasing. That means acceleration is also negative. So how will be the path diagram look like here? Velocity negative means it is going towards origin. Acceleration is also in this direction. So it will continue going in the negative x direction. Understood?
Yes, sir.
Come to the final. What is happening to the slope here, Xavier?
Sir, it's decreasing.
Yeah. So slope is decreasing. Slope is decreasing means velocity is decreasing. That means velocity is negative. Acceleration will be positive. So how will be the path diagram? Since velocity is negative, so it will be
It will
going
be in opposite
towards
direction.
origin and the acceleration will be in positive direction. Okay. So this is the whole story. Understood all the graph? First one is clear. Second, third, fourth, fifth, and sixth. I hope all the graphs are clean and clear. Any doubt?
No, sir.
Okay. Let me go ahead. So now we talked about x and t graph. Now let us talk about v and t. Velocity versus time. Velocity versus time. Velocity versus time and velocity versus time. So now here tell me guys. This is my first, second, and let me draw third and fourth. First case, what is the velocity? It is constant. Constant and positive. If velocity is constant, acceleration is 0. Come to second, what is dv by dt? The slope is
Uniformly constant, like uniformly increasing.
uniform. Yeah. So A is dv by dt, which is constant. So A is equal to constant here. And it is positive. So the both acceleration and velocity are in same direction. So that's why it is uniformly increasing. Understood?
Yes,
Here,
sir.
if the velocity was 0, then it will be 10, 20, 30, 40, like that, based on what is your acceleration. Okay. Similarly, come here, what is happening?
So here it is non-uniform.
Yeah, it's non-uniform, but still the V is increasing, right?
Increasing.
Yeah. So here, if I ask you, the acceleration at any point is also changing, right? Because A is what? dv by dt. This dv by dt is also changing, right? At any point, the slope of this graph is changing. So here A is also changing, correct? At any point, if I ask you, what is the acceleration? So you need to check what is the velocity at that time, correct? And then you need to calculate what is the acceleration. Understood? Similarly here, the velocity is decreasing continuously, correct? Decreasing or increasing? Increasing, but in negative direction. Here also acceleration is changing. Okay, as simple as that. So now you know that A is equal to dv by dt, correct? And v is equal to dx by dt. So if I take this formula, what will be my dx? V dt, correct? So if I integrate it from t1 to t2, from x1 to x2, so what will be this? This will be change in x, should be equal to integration of t1 to t2 into v dt. What this tells me is area under vt graph gives change in position or change in displacement. Okay. Similarly, A is equal to dv by dt, dv is equal to a dt. If I integrate from t1 to t2, v1 to v2, so the change in velocity is given by area under AT graph. Okay. So for example, if I tell you that I have figure like this, okay, this is, let's say, vt. Let's say this is 10, this is 2, this is 3, and this is 4. Okay. And let us say this is 5. So if I ask you, what is the displacement of this particle? What is the displacement of the particle? What is the displacement of the particle? Okay. What they have given? They have given velocity time graph. What you have to do? We already discussed in last slide that area under velocity time graph gives me the change in position, that is nothing but displacement. So that will be what? First you calculate, you divide the figure into rectangles, triangles, however you want. So I will divide it into this rectangle, this big rectangle, and then I will divide it in this triangle, and then I'll divide it in this rectangle, and then again I'll divide it in this rectangle. So what is the area of first rectangle? 10 times 2 plus what is the area of this triangle? Half. Base is 3 minus 2, 1. Height of the triangle is 10 minus 5, right? 5. Plus what is the area of this? The base is 1 and the height is 5. That is 5 plus what is area of this rectangle? This difference is 1, height is 5, again 5. So the total answer is 20 plus 2.5 plus 10, that is 32.5 meter. This is the displacement of the particle. Any doubt? Any doubt?
No, sir.
Yeah. So because we know that v is equal to dx by dt, dx is equal to v dt. Whichever comes in product, that will give you the displacement. or area under VT graph. Integration means what? It is area under the graph. You studied in class 12th, right? Now, if I give you the acceleration versus time graph, let's say if I give you like this, I have given you acceleration versus time graph. Let us say this is 5, this is also 5. Okay, so here if I ask what is the velocity of the particle, so you need to change in velocity of the particle from 0 second to 5 second. What you have to do, delta V is equal to area under this graph, half into base is 5, height is 5. So this is a what? 525 by 2, that is 12.5, right? Let's say if he says in the question the initial velocity was 5 meter per second, calculate the final velocity, then what you have to do, delta V is equal to 12.5. So delta V means what? V final minus V initial equal to 12.5. V final we want, V initial is given as 5 is equal to 12.5. So V final is equal to 12.5 plus 5, 17.5 meter per second. See, you go check anywhere. Everyone tells that area under AT graph gives the velocity. It is wrong. It gives the change in velocity. Okay. If they ask questions like this, then people will be stuck. You should not have any confusion. Understood?
Yes, sir.
Any doubt here?
No, sir.
No doubt? Very good. I will share these notes, okay? But please write it along with me. Who else joined the class? Let me see. Samhita. There are two Samhitas. Are those two different or same?
Different, sir.
Different.
Different Samhitas. Okay. So you guys know each other?
No, sir.
Okay. So it is accidentally met. Okay. No problem. So Samhita J,
Yes, sir.
you solving questions. How are you feeling about my lectures? I want to get a feedback also.
So, you explained differently from the lectures which I've heard till now. Sir. They are good, sir.
Okay, thank you. What about Samhita? Not dot J.
Yes, sir, they're good, sir. You're going at a pace I can understand.
Okay, no problem. Thank you, guys. So, but I have to see the result and I conduct exam. Today I'll upload, okay, questions. Please attempt the exam. Tomorrow evening I will see the results, okay?
Yes, sir.
I think 2 days we didn't do exams, right? Because I didn't cover much, so I didn't upload the questions. Okay, no problem. So let me just go ahead. So let me just summarize. What is the area under XT graph Qs, guys? Tell me what is the area under XT graph gives?
Velocity.
Nothing. It gives nothing. What is the area under VT graph gives? Change in position. So area under VT graph gives change in position. Area under VT graph gives change in position. Right? Delta x is equal to PDT. Integration means area under graph. Okay. And what is area under AT graph gives?
Change in velocity.
Yes, that word should come. Change in velocity. What is change in velocity means? Final minus initial. Okay. Now, let me just take some questions. Let me take some previous year questions. Okay. Let me just randomly search. These are simple questions, so I'm looking for a good one. Yeah, see, simple question. A particle has an initial velocity is given 3I plus 4J. Okay. And acceleration is given as 0.4I plus 0.3J. Okay. What will be its speed after 10 seconds? After 10 seconds, what is its speed? You do I component separately, J component separately. Finally, you need to tell. Okay. So see, you know, right? If I see only X component, what is the meaning of 0.4? In 1 second, the 3 will increase by 0.4. Correct? In 1 second, it will
Yes.
become 3.4. In 2 seconds, it will become 3.8. Correct? Like that, in 10 seconds, how much it will become? In 10 seconds, how much it will become? Xavier,
Yes, sir.
what will be the velocity after 10 seconds in X direction?
6 seconds?
Simple, you do. See, in 1 second, it is increasing by 0.4, right? So in 10 seconds,
Yes,
it will increase by 4.
4 seconds.
So total, 4 meter per second, right?
4 meters.
The total finally it will be 7. Correct?
Yes, sir.
So 7
sir.
I. And Y direction, it will also 7. Very good, 7J. So this will be your answer. They are asking speed. So you take magnitude 7 root 2, right? Under root 7 square plus 7 square. See, this is JEE advanced questions. How simple it is. You just know the concept. How much it will take? Hardly 5 seconds to solve this question. Okay.
Yes, sir.
1 second. Yeah. So the next question number is 2. A body is thrown vertically upwards. A body is thrown vertically upwards. Which one of the following graph correctly represent the velocity versus time? So the first option, second option, third option, and fourth option I will give you. Okay. The first option is like this. VT graph they have given. Okay. The second option is like this. The third option is like this. And the fourth option is like this. Okay. Tell me which is correct.
Sir, is it the first one?
Why?
Sir, because the velocity decreases
Okay.
until the top and then continues decreasing in the negative direction.
Yeah, so it will be like it will go, it will stop, right? It will become 0, then it increases continuously in negative direction, right? So when it was going up, the velocity was decreasing, but it was positive, right? So it was decreasing, now it became 0, then it changes its direction, reverse, right? And but it is increasing continuously in negative direction. So this is going to infinity. First option is correct. Right? Second is saying what? The velocity is decreasing, it became 0, again it is increasing. But it is increasing fine, but it is increasing in negative direction. You understood? If they said what is the graph of mod of v versus time, then second option is correct. Mod means what? We will flip this graph, right? The negative one will make it in the positive one. Then second option is correct. But here it is wrong. Correct? What about this? This is completely wrong. It is saying the from beginning itself the velocity is increasing. Correct? Then in fourth option doesn't make sense. Understood, Xavier?
Yes, sir.
Okay. So let me go to the next question. Next question is, all the graphs below are intended to represent the same motion. One of them does it incorrectly. Pick it up. Okay. The first one. He's saying all the graphs are representing same motion. Which one is not representing same? First one is distance versus time. Second one is position versus time. Then third one is velocity versus time. Fourth one is also velocity versus time. Okay. First one is like this. Okay. Second one is like this. Third one is like this. Fourth one is like this. Tell me guys, which one is wrongly represented?
So the option D1,
Why?
because like it is like fully negative.
Negative means what?
Like even the velocity as well as the acceleration, both of them are like negative.
See how you should approach. In the if you see this graph, right? Velocity, third option, if you see, we know that this is a graph of throwing a ball up. Correct?
Yes, sir.
Then if you see the second graph, if you see what is happening here, this is position versus time, that means x versus t only. So here what is happening to the slope? Positive. That means the velocity is positive, then the velocity becomes 0. Then again the velocity is, the slope is negative, that means the velocity is again increasing but in negative direction. So this and this are representing same. You understood my concept? Because this
Yes,
is
sir.
yeah. So because xt ग्राफ का स्लोप ही हमको वेलोसिटी बताता है. So xt graph slope, if I see, it is firstly decreasing here, right? In this half the slope is decreasing. Initially it was something, then finally it became 0. In this case also the velocity is decreasing, right? then it becomes 0, then it increases in other direction. Same thing happening in second also. In third graph, if you see what is happening for fourth graph, what is happening here? Velocity was some value before, then it is decreasing. Decreasing or increasing? Increasing. The slope is increasing. This is VT graph itself, right? So the velocity is decreasing. Initially it was 10, then it is 5, then 4, finally it became 0. Then what happened? 0, right? Then it was -5, let's say, then finally it reaches some -10. Correct? Now here the velocity is negative. Here the velocity is positive. Here the velocity was decreasing. Here the velocity is increasing. In this also, in this graph, velocity was sometimes it was increasing, then decreasing, then after one time it is increasing. Correct? Here also the velocity was decreasing for some time, then velocity was increasing. All these graph 1, 2, 3 and 4 are representing that the velocities for some time it is increasing, for some time it is decreasing. Correct? But in first option, if you see, in first option, if you see, what is it doing? Position versus time graph. The velocity is continuously decrease. First, see what is the slope here? 0, right? So then it started increasing. Correct? Increasing, then it became 0. Understood? Here also it is showing the velocity is increasing, decreasing, but the direction is not changing here. Is the velocity anywhere became negative in this first graph? Anywhere can you
No,
see
sir.
negative slope? So
No,
here
sir.
no negative slope. Or velocity is not negative. But in all other three cases, velocity is becoming negative. So the correct answer is option 1. Okay. So this is wrong, this is wrong, this is wrong, because they are representing same motion. First one is representing different motion. Hence they said us to pick up that graph. See how interesting these questions are. Just based on this slide. If you can understand this slide, you can solve that question. Easy peasy.
A little tricky, sir.
If you haven't understood, Xavier, I'll tell you, you spend some time. Then come to me.
Yes, sir.
Okay, until unless you fight yourself, nothing going to change. Okay. But you have understood
Yes,
my
sir.
first slide, right?
Yes, sir. Yes, sir. I understood
Yeah,
that.
if you have understood that, you have to understand that question. Spend some time. Okay, let me go for one more question. See, this question is also little bit good. What they are saying is a car starting from rest. Starting from rest means what is the initial velocity, guys? 0. See, this is how you should approach a question. Take the data line by line. I just read the first line, a car starting from rest. I wrote u initial is equal to 0. Accelerates at the rate of f through a distance s. Okay, then it starts accelerating. That means there was a particle, right? Then it was at rest, u was 0, then you applied some acceleration f. Okay, for how much distance? For s, this much distance you applied f acceleration. Correct? Now then through a distance s, then continues at a constant speed for time t. See, once it reached this much distance, we removed this f. It has acquired some speed now. Let's say the acquired speed is v. This has acquired this much speed because you were accelerating it. Now this became, now you removed this f, right? Then continues at a constant speed for time t. Then it moves with same v for time t. All right. And then decelerates at the rate of f by 2. Decelerates means what? Decreases. Decreases with a rate of f by 2. From here, it decreases with a rate of f by 2 to come to rest. Yes, it will come to rest finally, right? The v will become 0 because you are decreasing it. If the total distance traversed in 15s is 15s, they are saying the total distance traversed is 15s. This total distance is how much? 15s. Then they are asking what is the value of s. We need to find what is the value of s in terms of f and t. Okay. So what you have to do, you can use my concept of, I told you what is the meaning of acceleration, how you can relate it, right? Or what you can do is simply write, see, first distance, let's say this is s1. Okay. What is my s1? You know, s is equal to ut plus half at square. U is 0. So 0 plus half at square. Acceleration they gave as f, right? And here, let us say it takes time t1. Any doubt? No doubt. And for this much time, there is no acceleration. You can use your early class knowledge that velocity is equal to distance into time, right? V is equal to u plus at also you can use. V is equal to acceleration is 0 here, correct? Acceleration is 0 and it is taking time t. So here, how much is the distance? Can I write that distance? D is equal to velocity into time. Can I write, guys?
Yes, sir.
And then it decelerates. So this distance, can I write? S2 is equal to half. Here it has acquired some speed, right? So initial velocity is v into, let us say it takes a time t. It takes time t minus half. Why minus? Because it is decelerating. F by 2 into, let's say it takes a time of t2 square. Correct? Now, if I add all these distances, that is S1 plus VT plus S2, what I should get? 15s I should get. Correct? S1, you know, what is it? Half F T1 square plus VT plus S2 is what? VT minus half into F by 2 T2 square. Correct? Should be equal to 15s. So here, how many equations you have? One is, how many variables? T1 and T2, there are two variables. But I have only one equation. Or you can say, here you have one variable equation, here one more variable equation. Correct? So from where I will get one more equation? So that I can solve this. Two variables means you need two equations, right? So what will be that equation? Here it is given, right? S1 is given already. S1 is how much? It is S. They only given in the question that it travels a distance of S with an acceleration of F. Correct? So from here, what you do, you find the relation between S1, S2 and S1, S2 and then substitute. You will get two equations and two unknowns. You can easily solve it, get the value of T1 and T2. Then you can do the relation between S, T and V. Understood, or shall I explain it with other method? Hello.
Sir, can you explain it once more?
Okay, let me, if you are feeling difficulty here, let me approach with some other method. Let me explain it with graph. Velocity versus time graph. So initially it was at rest. Okay, here it was. Then it accelerates with uniform speed with F. With a slope F, it accelerates. Right? And then it becomes constant for some time T. They told that this time, right? This difference time is T. For T seconds, it remains constant. Then it decelerates with an F by 2. Correct? It decelerates with a
Yes, sir.
yeah, F by 2. So let me read it. A car starting from rest accelerates at rate of F through a distance S. Through a distance S means what? This area is given as S, right? Because area under VT graph gives me distance. Correct? Now,
Yes, sir.
yes. So what is this area? What is this area? This area is nothing but V into T. Correct? Now,
Yes, sir.
come here. What is this? What is this area? Finally, it says that then decelerates at the rate of F by 2 to come to rest if the total distance traveled in 15 second. Okay, he given time. So final time he is given as 15 second. Okay. In 15, yes, he said, that means it is a 15 second. Then what he's asking is, what is the value of this yes? So you know that this total area, how can you calculate this total area? You just add this area plus this area plus this area, right? You can do that.
Yes, sir.
Yeah, that's what I have written that in the form of equations. So here this area will be what? What is this velocity? Tell me. If this time is t1, what will be this velocity? F times t1, right?
Yes, sir.
So with F times t1, it acquires constant speed. It is moving with F times t1, right? Then it is decreasing. With what rate? F by 2. Now you understood what I'm saying. So can you say that this S is nothing but half into area of this triangle, half into base is t1 and height is F times t1. So can I say F by 2 into t1 square?
Yes, sir.
So that is your yes. How you will get this t1? That is the question. The whole challenge in this question is how you will get this t1. Since you know that they are saying that it is moving here with a velocity v, right? What is that v? F into t1, right?
Yes, sir.
Any doubt here? There should be no doubt because it has acquired this much speed. Now it is moving constantly with that much speed. So v is equal to f into t1. So from here you got t1 is equal to v by f. So just substitute here. So f by 2 into t1 is v square by f square. So you cancel out this. You got what? V square by 2f. Understood? So yes is
Yes,
this.
sir.
That's it. Is it simple?
Yes, sir.
Yeah. Just you need to stick to the basics. That's it. See what is happening. Don't go illogically. Go with the logic. You will get the answer. Okay, you guys practice some questions from any random book. Okay. So then you can let me know if you have any doubt. Okay.
Okay, sir.
All right, guys. Then
Okay, sir.
please let me know any other doubt if you have. I will just close this session. No doubt?
No
No
doubt,
doubts
sir.
yet, sir.
Also,
You are enjoying?
Yes, sir.
yes,
Okay. Samhita, work hard, okay? Both of you.
yes, sir.
Okay, all the best then. I'll upload questions, okay? You give the test. It will start from tomorrow morning 6 a.m. to evening 6 p.m. Okay?
Okay, sir.
Yes.
Okay. All the best, guys. See you. Bye.
Thank you,
Thank you,
sir.
sir.
Welcome.